On the morning of October 29th, 2025, at precisely 11:47 Coordinated Universal Time, an event occurred 203 million kilometers from Earth that no human eye could witness. 3I Atlas, the interstellar visitor that had captured the attention of the astronomical community since its discovery in July, reached Perihelion, its closest approach to our Sunday. For the first and perhaps only time in its billion-year journey through the cosmos, this enigmatic object slipped behind our star, hidden from every telescope on Earth and in orbit around it. Most comets are prisoners of celestial mechanics, their paths dictated by gravity with mathematical precision. Every position, every velocity can be calculated years in advance. Yet 3I Atlas presents a different story entirely. During those crucial hours when human observation was impossible, when our most powerful instruments were blind to its movements, this visitor from beyond our solar system may have executed maneuvers that defy natural explanation. The possibility exists that it performed what aerospace engineers call an Oberth maneuver, using the sun's immense gravitational field as a cosmic slingshot to redirect not itself, but objects it carried, toward the inner solar system, toward Earth. The European Space Agency's Jupiter Icy Moons Explorer, known as JUICE, was positioned 64 million kilometers away during perihelion passage. Though designed for studying Jupiter's moons Ganymede, Europa, and Callisto, mission controllers temporarily redirected its instruments toward 3I Atlas. They sought any data from this critical moment, any record of what the object looked like under maximum solar heating. 11 hours later, when the first data packets reached Earth and scientists in Darmstadt, Germany began processing them, an anomaly emerged that would transform speculation into genuine concern. 3I Atlas was brighter than predicted not marginally, but by nearly an entire magnitude. Comets can surprise observers with their brightness as volatile ices sublimate under solar radiation, releasing carbon dioxide, carbon monoxide, and water vapor. The models had predicted magnitude 11.5 at perihelion. JUICE's photometry registered magnitude 10.1, making the object 2.5 times brighter than expected. But luminosity alone wasn't the primary concern. The distribution of that light revealed something far more intriguing. Natural comets develop roughly spherical comas, perhaps elongated by solar wind into teardrop configurations, but generally centered on the nucleus. What JUICE captured defied this pattern. Multiple bright spots, 7 distinct luminous regions arranged around the central body, each exhibiting its own spectral signature, its own pattern of emissions. Between the beginning and end of JUICE's 42-minute observation sequence, these bright spots had moved. Not in the expected direction of ejected cometary material, following ballistic trajectories, but spreading out, diverging, and most remarkably, accelerating. Natural processes do not accelerate in vacuum. Once material is ejected from a comet, it obeys Newton's laws. It coasts. Solar wind and radiation pressure may influence its path, but these forces cannot cause sudden accelerations hours after initial outburst. Yet here were 7 objects, each roughly the size of a terrestrial school bus, based on brightness and distance calculations, exhibiting velocity changes suggesting active propulsion. The initial report was classified within hours and restricted to the International Asteroid Warning Network, the coordinating body for global response to potentially hazardous objects. By the evening of October 29th, 36 observatories across 4 continents had been alerted. Emergency observation protocols activated. Every telescope capable of slewing to the solar region was retasked. The Parker Solar Probe, NASA's sun-grazing spacecraft designed to study our star's corona, detected something equally puzzling. While not positioned to image 3I Atlas directly, Parker's instruments recorded a series of structured radio bursts coinciding with perihelion passage. These emissions centered around 1.420 gigahertz, the hydrogen line, that universal frequency emitted naturally by hydrogen atoms and monitored by researchers searching for extraterrestrial intelligence for precisely this reason. The Parker data revealed patterns, not random noise, not sporadic emissions from natural plasma interactions, but rhythmic pulses repeating in a specific sequence. 3 seconds, then 5, then 8, then 13, then 21. Each pulse lasting exactly as long as its numerical value suggested. The pattern continued. 34 seconds, 55 seconds, 89 seconds. The Fibonacci sequence, each number the sum of the two preceding it. This mathematical pattern appears throughout nature in flower petals, spiral galaxies, and countless other phenomena. It represents fundamental order. It announces mathematical awareness. And it was emanating from the direction of 3I Atlas at the exact moment of perihelion. The Fibonacci sequence does not appear spontaneously in radio emissions. Solar flares do not count. Plasma interactions do not solve arithmetic. Natural processes can create patterns, but not mathematical sequences requiring memory, requiring each emission to recognize what came before and calculate what follows. This represents information theory, signal structure, implying intent. The Parker data was immediately forwarded to the SETI Institute, to the Galileo Project, to research teams already analyzing 3I Atlas with increasing concern. On November 1st, the European Southern Observatory's Very Large Telescope in Chile reacquired 3I Atlas after it emerged from behind the sunday. The VLT, one of Earth's most powerful ground-based optical instruments, confirmed JUIC's observations with devastating clarity. The main body, that 5 to 20-kilometer nucleus tracked since July, remained intact, still following something approximating its predicted path. But surrounding it, spreading outward in what could only be described as a formation, were the 7 objects JUIC had detected. They had separated, each now millions of kilometers from the parent body, each on its own trajectory. 3 of them were not following paths that would carry them out of the solar system. 3 were slowing down, performing what aerospace engineers recognize as retrograde burns firing against their direction of motion to shed velocity. Orbital mechanics calculations revealed their new trajectories with uncomfortable precision. All 3 pointed toward the same destination, Earth. The projected closest approach date appeared repeatedly in calculations. December 19th, 2025. 50 days from discovery. Not the main body of 3I Atlas that would pass at its predicted safe distance of 270 million kilometers, but the probes, the 7 objects that separated at perihelion. 3 of them would arrive within 10 million kilometers of Earth. Less than 1/15 the distance to the Sunday 25 times closer than Earth's moon. JUIC's photometry suggested each probe measures at least 30 meters in diameter, larger than any satellite humanity has ever launched, larger than individual modules of the International Space Station. They are not tumbling randomly like debris. They exhibit 3-axis attitude control, the same stabilization system used on advanced spacecraft. Photometric observations reveal periodic brightness variations with cycles of precisely 16.2 hours, the same rotation period exhibited by 3I Atlas itself. Whatever detached from the parent body appears to have maintained rotational synchronization even after separation. Multiple independent observatories, using different instruments and methodologies, have reached the same conclusion. Something extraordinary happened at perihelion, something natural comets do not do. The International Asteroid Warning Network convened its first emergency session since its founding on November 2nd. Representatives from NASA, ESA, Roscosmos, JAXA, CNSA, and every major space agency participated, along with astronomical societies from 37 countries. Though the meeting was closed, agenda items leaked within hours. Confirm trajectories of all 7 objects. Assess probability of natural versus artificial origin. Determine Earth impact risk. Establish communication protocols. Authorize defensive measures. That final item captured global attention. If something approaches Earth and intentions cannot be determined, options must exist. Options to observe, certainly, but also to intercept, deflect, or if necessary, destroy. The United States Space Force has been quietly activating satellite tracking networks, retasking systems designed to watch for missile launches to monitor the region where the 3I Atlas probes travel. Ground-based radar installations are being recalibrated. In classified facilities, engineers run simulations, attempting to determine if humanity's most powerful rockets could reach the probes before they reach Earth. Yet here emerges a profound paradox. Even with capability and certainty of success, destroying these objects might constitute the most catastrophic mistake in human history. If they represent the first confirmed contact with extraterrestrial technology, destroying them would announce humanity as violent and paranoid to whatever intelligence sent them. The evidence needed to understand who created them, why they're here, what they seek, would be obliterated. And so the global community watches, tracks every kilometer of approach, points every available instrument toward these visitors, collecting spectroscopy, photometry, radar returns, monitoring across every accessible frequency, preparing quietly for the possibility that December 19th will be remembered as either humanity's greatest day or something far darker. The probes move at approximately 68 kilometers per second, relative to the Sunday fast by terrestrial standards, but slow for interstellar objects. 3I Atlas itself was measured at 221,000 kilometers per hour at discovery. These probes have shed enormous velocity. The energy required for such deceleration staggers comprehension. Even assuming minimum mass based on observed size, calculations suggest energy expenditures equivalent to multiple nuclear detonations per probe. This is not outgassing. This is not solar wind pressure. This is propulsion fuel being consumed, reaction mass expelled, engines firing in the vacuum of space. This raises the question researchers hesitate to voice publicly. If these probes possess sufficient fuel to decelerate so dramatically, do they retain enough to accelerate again? Are they on one-way observational missions, or capable of further maneuvering entering Earth orbit, descending toward the surface, executing whatever purpose guided their creation? The answer remains unknown, perhaps the most honest and unsettling response science can provide. The mathematics of perihelion maneuvers reveal elegant brutality. 3I Atlas approached at 68 kilometers per second, velocity oriented primarily toward interstellar space following its hyperbolic trajectory. Redirecting even small mass toward Earth requires rotating that velocity vector through nearly 90 degrees. Energy costs scale with the square of velocity change. For 30-meter objects achieving the observed trajectory alterations, each probe would require fuel mass equal to roughly 40% of total launch mass. Assuming specific impulse, comparable to humanity's best chemical rockets. If more exotic propulsion systems are employed, nuclear thermal, fusion, antimatter ratios change, but fundamental physics cannot be circumvented. Dr. Sarah Chen at MIT's Aeronautics Department calculated requirements using optimistic projections for advanced propulsion. Even assuming fusion drives operating at specific impulse values 10 times superior to human achievement, fuel requirements remain staggering. This represents either technology thousands of years beyond current human capability or fundamental breakthroughs in physics, enabling propulsion without reaction mass. Either prospect is sobering. The timing of the separation event adds another layer of significance. Perihelion isn't merely convenient for releasing probes toward inner solar system targets, it's optimal. The Oberth effect. When deep in a gravity well, moving at maximum velocity, every unit of thrust produces amplified results. Firing engines at perihelion yields more change in orbital energy per unit fuel than any other point in the trajectory. This is fundamental orbital mechanics, known since Tsiolkovsky articulated the rocket equation over a century ago. That 3I Atlas performed this maneuver at the precise moment of maximum efficiency suggests planning, understanding of local gravitational environment. Natural comets don't wait for optimal moments because they lack goals. And Earth wasn't watching. Solar conjunction happens predictably. When 3I Atlas was discovered in July, orbital calculations immediately revealed it would pass behind the Sun from Earth's perspective in late October. That's geometry, not conspiracy. But perihelion occurring precisely during that blackout window, when no telescope on Earth or in orbit could observe directly, when even closest spacecraft caught only oblique glimpses, that timing is remarkable. Statistical analysts examining the object's trajectory backward, accounting for galactic rotation and stellar motions and gravitational perturbations from known objects, find its origin point stubbornly fixed near the galactic center. Not from a specific star that precision is impossible over such distances and timescales, but from that general region where stellar density peaks and extreme gravitational environments dominate. 26,000 light-years from Earth lies Sagittarius A star, the supermassive black hole anchoring our galaxy's core, massing 4 million times our sunday. Around it, stars crowd together with separations measured in light days rather than light years. It's violent, dynamic, nothing like the quiet galactic suburbs where Sol peacefully orbits. From that direction, from that maelstrom of stellar activity and extreme physics, 3I Atlas emerged after billions of years of travel. There exists another signal from that direction, one that refuses explanation despite decades of scrutiny. August 15th, 1977. The Big Ear radio telescope in Ohio detected a signal so strong, so precisely confined to the hydrogen line frequency, that the astronomer reviewing data the next day scrawled, "Wow," in the printout margin. That exclamation became its name. 72 seconds of narrowband radio emission arriving from Sagittarius. Big Ear never heard it again. Follow-up observations found nothing. Decades of searching that patch of sky have yielded only silence. Recent analysis suggested the signal might have come from a comet, specifically 266P divided by Christensen, transitioning that region in 1977. Comets can emit radio radiation through hydrogen cloud processes. But the signal was too strong, too focused, too brief. When other researchers checked orbital calculations, the proposed comet wasn't actually positioned correctly to produce the observed signal. The mystery endures. Now, 3I Atlas arrives, another visitor from Sagittarius, carrying not just radio signals, but physical presence, mass, velocity, structures, possibly artificial. Two anomalies from the same direction across half a century. The galactic center occupies roughly 1% of the sky as seen from Earth. If anomalies arrive from random directions, probability of two independent events both originating from that 1% is 1 in 10,000. Add narrowband radio emissions, and the probability drops further. Add the hydrogen line frequency connection and coincidence begins appearing less plausible than correlation. Some researchers suggest the WOW signal might have been an intentional beacon, a hailing frequency designed to announce an incoming visitor. 48 years from signal to arrival sounds lengthy by human standards. But for interstellar travelers, for civilizations capable of crossing light years, such timescales might be routine. Send a signal ahead, provide notice, arrive decades later to determine if anyone responded. It's what humanity would do with such capability. The constellation's position isn't arbitrary. Sagittarius sits on the ecliptic, the plane where planets orbit. 3I Atlas's trajectory aligns within 5 degrees of that plane, an orientation with only 0.2% probability for random interstellar objects. But for targeting a solar system, for planning survey missions or contact attempts, approaching along the ecliptic makes strategic sense. That's where interesting destinations exist. Rocky inner planets, gas giants, asteroid, and Kuiper belts. An approach perpendicular to the ecliptic minimizes time in the plane where targets reside. An approach along it maximizes interaction possibilities. The probes now carry designations, Probe 1 through Probe 7, uninspired but functional. Each represents a 30-meter mystery hurtling through space with purposes humanity can only speculate about. Probe 1, the largest and brightest, maintains its trajectory toward Earth. Refinements with each night of observation confirm the same conclusion. Closest approach December 19th at 3:15 Universal Time, distance 8.7 million kilometers. Velocity at encounter approximately 45 kilometers per second. That velocity is slow for an interstellar object, but insanely fast by human standards, 9 times faster than humanity's fastest spacecraft. Fast enough to cross the Earth-Moon distance in under 3 hours. But what distinguishes Probe 1 is its continuing deceleration. The object is still slowing down, still shedding velocity at measurable rates. Its engines, whatever form they take, are still firing, still consuming fuel or reaction mass, still producing thrust days after initial separation at perihelion. Natural objects don't do that. Once separated from a parent body, once given initial velocity by whatever ejection process launched them, they coast. Conservation of momentum. Newton's first law. An object in motion remains in motion unless acted upon by external force. Probe 1 is being acted upon by an external force, its own propulsion system. The thrust profile, the pattern of deceleration over time, appears controlled. Not constant thrust like chemical rockets burning to exhaustion, but variable thrust increasing and decreasing in patterns, suggesting active guidance. Someone or something is steering, making course corrections, fine-tuning trajectory, ensuring arrival at specific target points in space and time. Dr. Margaret Healy-Ongwo at NASA's Jet Propulsion Laboratory has been modeling Probe 1's trajectory with increasingly sophisticated algorithms. Her latest projections reveal something transformative. If Probe 1 continues its current deceleration profile for another 3 weeks, it will match Earth's orbital velocity, not pass by at 45 kilometers per second, but pace humanity's world. It will achieve what orbital mechanics terms a rendezvous trajectory, 2 objects arriving at the same point with similar velocities, enabling extended interaction. That capability changes everything. A probe capable of rendezvous with Earth can potentially enter orbit, taking up station at fixed distance, observing for extended periods, months, years perhaps. It can study humanity in detail, monitoring cities and communications and activities, compiling comprehensive intelligence on this technological species it has encountered. Probe 2 follows a different trajectory entirely. Closest approach December 20th at 1740 Universal Time, distance 9.2 million kilometers, but its velocity curve differs. Instead of steady deceleration like Probe 1, Probe 2 maintains nearly constant velocity with only minor corrections. It will pass Earth at 48 kilometers per second, close enough for excellent remote sensing, too fast for capture or rendezvous. Its post-encounter trajectory projects outward toward the outer solar system, suggesting reconnaissance rather than close study. Observe and report. Don't linger. Probe 3 remains enigmatic. Its orbit has been hardest to constrain, complicated by apparent trajectory changes that don't follow simple ballistic curves. Some observations suggest it's performing small course corrections every few days, adjustments too precise for outgassing effects. Latest orbital solutions place closest approach December 18th at 10.1 million kilometers. Though those solutions carry large uncertainties, that won't resolve until radar tracking becomes possible mid-November. What makes Probe 3 particularly intriguing is its rotation state. Unlike Probes 1 and 2, which maintain stable spins with regular 16-hour periods, Probe 3 appears to be tumbling. Brightness variations are chaotic, suggesting uncontrolled rotation around multiple axes. This could indicate damage something that malfunctioned during separation from the mothership. Or it could be intentional, a probe designed to sample space environment from constantly changing orientations, maximizing data collection by exposing different sensor suites to varying aspects. Probes 4 and 5 target Venus, their trajectories bending inward toward the Sun rather than outward. Venus reaches inferior conjunction, its closest approach to Earth, in January when these probes will arrive. Venus presents hellish conditions: 800 degrees Celsius, crushing atmospheric pressure, clouds of sulfuric acid. Nothing humanity has sent there survives more than hours before succumbing to heat and corrosion. But Venus represents a laboratory for studying extreme greenhouse effects, atmospheric superrotation, boundaries of planetary habitability. For surveying a solar system, for understanding the full range of terrestrial planet conditions, Venus provides essential data. The Venus probes appear smaller than their Earth-directed cousins, or at least dimmer, suggesting either reduced size or different surface properties. They're not decelerating as aggressively, which makes sense. Venus possesses thick atmosphere enabling aerobraking. If these probes are designed for atmospheric entry, they wouldn't need as much propulsion fuel. They could dive in, letting friction do deceleration work, though they would require extraordinary thermal protection to survive even brief exposure. Probe 6 targets Mars, following the slowest, most leisurely path. Its gentle curving trajectory will bring it near the red planet in March 2026, 4 months hence. Mars currently sits on the far side of the Sun from Earth, geometrically separated, but accessible to a probe with patience and fuel. The Mars trajectory requires less delta-v than Earth trajectories because Mars orbits higher in the Sun's gravity well, moving slower. It's actually the most energy-efficient target among inner planets for something approaching from interstellar space. But Mars possesses something Earth lacks: unambiguous evidence of human presence. Rovers and landers, orbital satellites, infrastructure for eventual permanent settlements. For studying technological species, Mars reveals expansion capabilities, reach beyond homeworld, whether a civilization remains confined to one planet or spreads outward. Probe 6 will observe human off-world infrastructure, assuming it approaches closely, and Martian assets remain functional at arrival. The 7th probe, the Outlier, heads away back toward gas giants, following trajectory that will pass Jupiter in June 2026, 8 months hence. Jupiter is planetary royalty, 300 times Earth's mass, a scaled-down star that never achieved fusion ignition. Its magnetic field is enormous, radiation belts deadly, moons a collection of alien worlds ranging from volcanic Io to ice-covered Europa to massive Ganymede with its subsurface ocean. Jupiter represents completely different planetary environment than rocky inner worlds. Surveying it completes the dataset. Probe 7 is also the brightest after Probe 1, suggesting comparable size or higher reflectivity. Its trajectory matches 3I Atlas more closely than any other probe, as if escorting the mothership, maintaining formation as both head outward. Some analysts speculate this might be the communications relay, the probe responsible for gathering data from 6 siblings and transmitting consolidated reports back to 3I Atlas or beyond. If you're sending probes to 7 different targets, some mechanism must exist to collect findings. Probe 7 could be that central hub, mission coordinator ensuring all data reaches home. The separation event itself remains mysterious. JUICE observed the aftermath 7 objects already distinct and spreading, but didn't capture the moment of release. What forces were involved? Did 3I Atlas fragment violently, breaking apart under thermal or tidal stress? That explanation fails because the mothership remains intact, following original trajectory with no apparent mass loss, beyond normal cometary outgassing. Did it eject probes mechanically using launching systems, spring-loaded mechanisms, compressed gas ejection, electromagnetic catapults? Those are technologies humanity understands, scaled to alien engineering standards, but conceptually familiar. Or was it gentler? Did probes detach and drift away under minimal impulse, then activate their own engines once clear? That would minimize mechanical stress, allow more controlled separation, but requires probes to carry propulsion from the start, adding mass and complexity. Either way, the separation was planned. 7 objects don't spontaneously arrange themselves into trajectories targeting 7 distinct solar system bodies by accident. The targeting alone requires navigation data, knowledge of where planets will be months in future, calculations accounting for gravity, orbital motion, interception, geometry. Radio silence lasted exactly 9 days from perihelion on October 29th until November 7th. The Allen Telescope Array in California, Parkes Observatory in Australia, Effelsberg Dish in Germany, every major radio telescope capable of monitoring hydrogen line frequency listened, recording endless hours of cosmic noise. Natural radio emissions from Jupiter, solar radio bursts, galactic background hiss, all the usual suspects, but no Fibonacci sequences, no structured patterns. Then November 7th, 2:37 Universal Time. The Very Large Array in New Mexico detected something, not from 3I Atlas itself, which remained radio quiet, but from Probe 1. A burst of narrowband emission centered at 1.420 gigahertz, lasting 3.14 seconds, then silence for 5.08 seconds, then another burst 8.04 seconds long, then 13.10 seconds of silence. The pattern continued for 26 minutes. Burst, silence, burst, silence. Each transmission longer than previous by the sum of the two before it. 3, 5, 8, 13, 21, 34, 55, 89, 144. The Fibonacci sequence again, unmistakable and deliberate. But this time, there was more. Within each burst, within those precisely timed transmissions, structure existed modulation, information encoded in variations of signal strength and frequency. Rachel Kim at the SETI Institute leads analysis of those transmissions. Preliminary results are simultaneously frustrating and tantalizing. The modulation isn't random, that much is clear. It shows regularities, patterns within patterns suggesting intentional encoding rather than natural variation. But extracting meaning from those patterns has proven extraordinarily difficult. Humanity is attempting to decode messages from a civilization about which nothing is known, using mathematical relationships assumed universal but possibly implemented in unanticipated ways. Kim's team has tried everything, treating modulation as amplitude encoding, frequency encoding, phase encoding, searching for prime numbers, mathematical constants, geometric ratios, testing whether signals might represent images one-dimensional data assembled into two-dimensional pictures. Nothing has worked definitively. Everything works partially, producing results that appear almost meaningful, but never quite resolve into clear information. It's like tuning a radio to a station slightly off frequency. Fragments appear, hints of structure, but never full clarity confirming comprehension. This frustration is exactly what first contact theorists predicted. Communication between species that evolved independently, that developed mathematics and logic and information encoding through potentially divergent paths, was never going to be straightforward. The hydrogen line frequency provides universal common ground, a wavelength any technological civilization would recognize. But once that shared channel is established, conveying complex information requires common assumptions about data structure that may not be shared. There's a philosophical argument that mathematics is universal, that 1 + 1 = 2 everywhere in the universe, that geometric relationships and physical constants provide objective common ground. But implementation matters. Humanity uses base 10 because we have 10 fingers. A species with different anatomy might use base 8 or 12 or 16. We represent numbers as sequential symbols arranged left to right. They might use something completely different. Underlying mathematics might be identical while notation remains mutually incomprehensible. Kim's latest approach treats transmissions as tutorials attempts by Probe 1 to teach humanity its encoding scheme. That's what we would do when attempting communication with newly discovered intelligence. Start simple, establish basic correspondences, build gradually toward more complex concepts. The Fibonacci sequence itself might constitute Lesson 1, demonstrating shared knowledge of mathematical patterns. Subsequent transmissions might introduce additional concepts, creating vocabulary both sides understand, but that requires time and patience and ongoing dialogue. If Probe 1 transmits once every few days, and each transmission adds small information increments, weeks or months might be needed to build sufficient shared understanding for meaningful content exchange. Humanity has 42 days until arrival. 42 days to progress from, "we both know Fibonacci numbers," to, "here's what we want, and here's what you should do about it," unless we respond. Unless we transmit back, acknowledging receipt and demonstrating our own mathematical knowledge. The debate over whether to respond has intensely divided the scientific community and government advisors into camps with fundamentally different perspectives on risk and opportunity. One side argues for immediate response. Every silent day is wasted opportunity to establish communication and begin understanding. If Probe 1 attempts contact, silence might be interpreted as hostility or incomprehension. Humanity could miss the only chance ever to converse with extraterrestrial intelligence because of excessive caution, fear of hypothetical consequences, and what could possibly be said to make things worse. If they intended harm, they wouldn't need permission or provocation. If peaceful, ignoring communications attempts seems counterproductive. The other side counsels caution. Nothing is known about these visitors, nothing about intentions, capabilities, or the civilization that sent them. Responding confirms human presence and technological status, eliminates ambiguity about whether Earth hosts intelligence. It also reveals information about human mathematics, communication protocols, level of advancement. That information might be valuable, might be precisely what they seek. Giving it freely without understanding why they want it could be catastrophically foolish. History overflows with cautionary tales about civilizations revealing themselves to more powerful neighbors. First contact doesn't always end well for the less advanced party. For now, officially, humanity listens without transmitting. International Academy of Astronautics protocols for responding to extraterrestrial signals recommend exactly this approach. Confirm detection, analyze content, consult with international bodies, then and only then consider response options with input from humanity as a whole rather than individual nations or institutions. Those protocols were developed for signals from distant star systems, from civilizations light years away where response time would be measured in decades. Nobody anticipated needing them for objects approaching Earth on timescales of weeks. Unofficially, some groups are less patient. Amateur radio astronomers with powerful transmitters have been pointing at Probe 1, sending their own messages, mathematical sequences, prime number lists, images of Earth and human faces, recordings of music and natural sounds. The cosmic equivalent of throwing everything at a wall to see what it hears. Those transmissions are uncoordinated, mutually contradictory, probably just adding noise to any legitimate communication attempt. But they're happening regardless, because telling amateur astronomers not to do something proves about as effective as commanding tides. China has taken its own approach. Tianwen-2, their asteroid sample return mission launched in May, has been quietly retargeted. Original objectives involved collecting material from near-Earth asteroid 2016 HO3 and returning it to Earth. But with flexible enough propulsion margins and careful trajectory planning, the spacecraft could instead rendezvous with one of the three I-Atlas probes. Not Probe 1 that's too fast and distant, but possibly Probe 3 or 6, depending on orbital geometry. Tianwen-2 carries instruments for compositional analysis, cameras for detailed imaging, even a sampling arm that could theoretically collect material from a probe surface if approached closely enough. Scientific return would be invaluable. Direct observation, chemical analysis, maybe even samples of extraterrestrial technology. But risks are enormous. What if the probe interprets close approach as hostile? What if it possesses defensive systems humanity can't anticipate? What if China's unilateral action triggers responses from probes affecting everyone, not just the acting nation? NASA knows about Chinese plans. Satellites capable of tracking asteroid missions can also track course changes and trajectory intentions. Strongly worded diplomatic exchanges have occurred, threats of sanctions, accusations of recklessly endangering humanity for national prestige. But China isn't retreating from their position. They argue, with some justification, that gathering direct data on probes is essential regardless of who accomplishes it. Better to know what humanity faces than remain ignorant until December 19th. And if they happen to gain exclusive access to revolutionary alien technology in the process, well, that's simply fortunate side effect of bold scientific initiative. The signals continue every 3 to 4 days. Probe 1 transmits again. Same frequency, same Fibonacci timing, slightly different modulation patterns each time. Data is being meticulously archived. Multiple institutions maintain independent copies, ensuring nothing is lost if individual systems fail. Analysts compare transmissions, searching for evolutionary patterns, attempting to determine if the probe repeats information or builds on previous messages. One fascinating detail emerged from comparing November 7th and 11th transmissions. Signal strength varies in a pattern matching no known physical process. It's not inverse square law natural fall-off of signal intensity with distance. It's not modulated by rotation or orientation changes. Instead, variations appear deliberate, as if the probe adjusts transmission power to ensure consistent received strength at Earth despite increasing distance. That implies knowledge of Earth's location and receiver sensitivity information the probe shouldn't possess, unless it's been observing humanity longer than we've been aware of it. Or unless it received information from 3I Atlas. The mothership had months to study Earth while approaching months to map radio emissions, television broadcasts, radar transmissions. All that data, all those inadvertent signals humanity leaks into space simply by operating technological civilization, could have been analyzed and compiled into comprehensive briefing. Probe 1 might know everything about humanity that electromagnetic radiation can reveal: all languages, communication protocols, technological capabilities, while we know essentially nothing about it beyond trajectory and timing. That asymmetry is profoundly uncomfortable. Humanity is the transparent party, broadcasting everything about ourselves to anyone with receivers and processing capability. They remain enigmatic, revealing only what they choose through carefully controlled transmissions. It's opposite of how first contact scenarios usually unfold in fiction, where Earth sends messages and waits hopefully for response. This time they transmit, and humanity tries deciding how to respond, conscious that whatever is said or done might be monitored, analyzed, fed into decision-making processes we don't understand. Spectroscopic observations of Probe 1 reveal emissions characteristic of hydrogen cyanide, that famous poisonous compound disrupting cellular respiration. Comets produce cyanide naturally, breaking down organic compounds under solar ultraviolet, so its presence isn't automatically suspicious. But concentrations are wrong far too high for normal cometary chemistry, especially for an object that's separated from its parent body weeks ago and should have stopped producing new volatiles. Hydrogen cyanide is also interesting from chemical signaling perspective. It's simple enough to produce deliberately just carbon, nitrogen, and hydrogen in proper configuration. It has strong spectral signatures easily detectable at interstellar distances. And it's toxic to life as humans understand it, a universal warning signal that something might be hazardous. Is Probe 1 communicating danger, indicating it carries payloads humans wouldn't survive exposure to? Or does cyanide serve some other function, propulsion-related perhaps, or just a byproduct of whatever reactions power its systems? The defensive posture is exhausting. Maintaining high alert, keeping systems ready and personnel trained, costs resources and attention that can't be sustained indefinitely. If probes arrive and nothing happens, if they observe and depart without incident, relief will be enormous, but so will backlash. Politicians will face questions about wasted budgets and unnecessary panic. Military leaders will defend their caution, pointing out that preparation prevented worst-case outcomes even if those outcomes never materialized. And society will collectively attempt forgetting how close it came to decisions that cannot be retracted, actions that would have defined humanity's character in whatever intelligence's eyes might be watching. December arrives and time compresses. Days feel shorter as the 19th approaches, urgency building despite nothing changing in daily routine. Weather continues its business rain, snow, sunshine, following seasonal patterns without caring about cosmic visitors. Birds migrate. Trees stand bare or evergreen depending on species. The biosphere continues ancient rhythms, undisturbed by human concerns about what approaches from space. Tracking precision improves with each passing day as range decreases and observing angles optimize. Probe 1 will pass at 8.6 million kilometers, refined from earlier estimates, at 3:22 Universal Time on December 19th. That's 22:22 Eastern Time on December 18th, 1922 Pacific. Different time zones mean different dates, appropriately confusing for an event transcending earthly geography. The night of December 18th is clear across much of the northern hemisphere, fortune, or providence providing good observing conditions at the critical moment. Astronomy clubs host viewing parties, people gathering with telescopes and blankets and thermoses of coffee to watch probes crossing their closest approach points. Most won't see anything, objects are too faint for casual observation, but being outside, looking up, sharing experience with others provides comfort and community that watching television alone doesn't offer. Professional observatories have every instrument trained on approach zones. Cameras record continuously. Spectrographs analyze any emissions. Radar systems bounce signals and measure returns. Data rates are overwhelming terabytes flowing every hour, straining storage systems and network bandwidth. Analysis will take months, but collection happens now. This brief window when probes are close and observable might be the only chance humanity gets. And so we wait. Humanity holds its collective breath, watching space and wondering. 48 hours until December 19th. 48 hours until we discover if we're alone or accompanied, threatened or welcomed, on the verge of transformation, or simply witnessing the most remarkable natural phenomenon in recorded history. The probes approach, the signals continue, and Earth spins on, carrying 8 billion souls toward an appointment none of us chose but all of us must keep.